So today we are going to begin our class with the measure of variation. We have started measure of variation in last class, and we work on one measure of variation, that was the range. Now today we are looking at second measure of variation. It is called standard deviation. This is a used concept in this course, and each one of you must know how to calculate standard deviation in different situations. So let's first go over some basic theory of standard deviation, and then we'll go to the calculation. First, we are going to look at the definition of standard deviation. When we say standard deviation, it is the square root of variance. That means when you find this standard deviation, one thing you'll be doing is you'll be calculating the square root, and you are calculating the square root of variance. So what is variance? That is something we need to know. Variance is the average of square of the distance each value is from the mean. That is the definition, or that is the meaning of variance. Variance is the average of the square of distance each value is from the mean. So that's why sometimes the variance is also called the mean square deviation. This is also called, or the standard deviation is also called the mean square deviation. Deviation or distance from the mean. So you can see that as the standard deviation involves the calculation of a square root of variance, and variance is the average of the square of the distance from the mean, the first thing that we must do while calculating the standard deviation is finding the mean. And we already learned how to find mean in previous class. So for population, the standard deviation is denoted by this lowercase Greek letter, which is called the sigma. This is the lowercase Greek letter, sigma. And for the sample, the standard deviation is denoted by the lowercase English alphabet s. In simple language, we can say that standard deviation, it measures the dispersion of the data about the mean. How much the data is scattered about the mean, that is what we get by calculating standard deviation. Here we have a few things that we need to know. The first one is the square of the standard deviation is the variance, because standard deviation is the square root of variance. So the variance is other way around. If we square the standard deviation, then we get the variance. We denote variance like this. Sigma square is variance, s squared is variance. Sigma squared for population and s squared for the sample. Also, after we know the standard deviation, we also calculate the coefficient of variance. The coefficient of variance is standard deviation divided by mean and expressed as percentage. Please copy these formulas. So the coefficient of variance, just write CVAR, coefficient of variance, is equal to, in the numerator, you have S or sigma, that is standard deviation, divided by, in the denominator, you have X bar or mu, that is the mean, okay? And we multiply that by 100%. So if we perform that calculation, we get the coefficient of variance. And we already know how to calculate the range in a previous class. So if you divide the range of the data by 4, it is approximately equal to standard deviation. Not exactly, this is not the way we calculate. That's why there's the approximate sign there. And this is called the rule of thumb. If you quickly look at the range and divide it by 4, the standard deviation is approximately equal to that. Not exactly equal to, but approximately equal to. So once we have the basic idea about the meaning of standard deviation, we are going to look at the formulas for calculating the standard deviation. So here we have 4 important formulas for calculating the standard deviation. I want you to copy these formulas. The first 2 formulas are for population, and second 2 are for sample. The only difference is in population, we write the standard deviation by sigma, whereas in sample, we denote by s. And then for the population, the mean is denoted by mu. Here in sample, the mean is denoted by X bar. And inside the square root, you can see in case of population, we divide by n, the uppercase n, that is the sample size. Whereas for sample standard deviation, we divide by n minus 1, that is the size of the sample minus 1. So these are the 4 important formulas that we'll be using today for calculating the standard deviation. Please copy this formula. I'm going to give you about a minute to do this. Okay, are we done copying? Yes or no?
Almost.
Okay. Okay, now we are going to continue with the example on calculation of standard deviation. Can you see the example shared with you?
Yes.
Yes.
Okay. Okay. So make sure you are also ready with your calculator because you'll also be calculating along with me. So here in this problem, you can see we are asked to find the population standard deviation. When it says population standard deviation, you are calculating sigma. Population standard deviation is sigma. You are also calculating the variance. So it is for the population. So it is sigma squared. And then you are also calculating the coefficient of variance. Let me write CVAR for that. So we are using those formulas over here. And the data given here is individual series. This is not a group data. This is on group data. And you have seen that for on group data or individual series, the formula to find the standard deviation was sigma equal to summation x minus mean quantity squared divided by n. So that was the formula. So as I mentioned before, the first thing we need to do is we need to find the mean. We need to find this mu. So in the calculation of a standard deviation, the first thing we do is we find the mean. So here, because this is the individual series, we add all these numbers and divide by the number of observation, which is 1, 2, 3, 4, 5, 6. So let's find mean first. You can copy all these along with me. Mean mu is equal to 10 plus 60 plus 50 plus 30 plus 40 plus 20 all divided by 6. So if you add these numbers 10, 60, 50, 30, 40, 20, do it in your calculator. I hope it is 210. And divide that by 6, you should get a 35. Please check that. So you should get 35. So that is the mean. So after we have the mean, let's try to get this value. We need x minus mean squared. So these values which are here, this is our x. Okay, so the x is already given to you. So x are 10, 60, 50, 30, 40, and 20. These are your x values. Next, what we need is we need to find x minus mean, and we have to square that. So in next step, let's find x minus mean. So x minus mean. So x is 10 here. The first one is 10. Mean is 35. So 10 minus 35. If you perform that calculation, 10 minus 35 is negative 25. Next line, 60 minus 35, which is 25. Next line, you have 50 minus 35, which is 15. Next, we have 30 minus 35 is negative 5. Next, we have 40 minus 35 is 5. Next, we have 20 minus 35 is negative 15. Okay, do you have any question up to here? Just say yes or no.
No.
No, sir.
Okay, okay, great. So we got x minus mean, but what we need in our formula is x minus mean quantity squared. So in next column, I'm going to find x minus mean quantity squared. Let's do that. So x minus mean is negative 25. Square of negative 25, which is negative 25 times negative 25 is 625. The next we have 25. 25 squared is 625. Next we have 15. 15 squared is 225. Next we have -5. -5 times -5 is 25. Next we have 5. 5 times 5, 25. And then here we have -15. -15 times -15 is 225. So we got all those values. Now, if you look at the formula to find the standard deviation, it is the square root of the sum of this sign here, sigma, uppercase sigma. That is uppercase sigma. This is lowercase sigma. Uppercase sigma is the sum. Lowercase sigma is the standard deviation. So here we have the sum of x minus mean quantity squared. So here we have x minus mean quantity squared. Now we have to add all this. So let me write that formula and begin that calculation. Now, the standard deviation sigma is the sum of these values, sum of x minus mean squared. Please add these numbers in your calculator and tell me what you'll get. Please add those numbers along with me. I'm also adding here. 625 plus 625 plus 225 plus 25 plus 25 plus 25 plus 225 at the end. What did you get?
1750.
I get 1750 also. And then divide that by 6. Okay, that's how you'll write. Now that is equal to, now please follow along with me in your calculator. What you'll do is you're going to type this square root sign first in your calculator in order to evaluate this. So square root sign is underneath that square. Okay, it is underneath that square. So please type that second and then square, that will give you square root sign. And then type 1750 slash 6 or divided by 6. 1750 divided by 6. What did you get?
17.078.
17.0783. That's right. So that is the standard deviation. Okay, we got the first answer, population standard deviation. Now, after we get the population standard deviation, next we have to get is the variance. So variance, you can write this variance, which is sigma squared is equal to square of that standard deviation. So that's my standard deviation, 17.0783. We need to square that. Please square that in your calculator, 17.0783, and square that. What did you get?
291.66.
291.6683. I think I told you if I am using my calculator and the number of decimal is not mentioned, I'll be writing all my answers to 4 decimal places. So make a habit of that. Now, the next one, we need the coefficient of variance. How do we find the coefficient of variance? What was the formula? Coefficient of variance is equal to, it is equal to standard deviation by mean. So standard deviation is this, 17.0783 divided by mean. We got mean here, that was 35. Okay. And multiply that by 100 to get this in percentage. So please type this in calculator, 17.0783, divide that by 35 and multiply by 100. 17.0783, divide that by 35. And once you get the result, multiply that by 100. What did you get?
48.7951.
That is right, 48.7951%. So this is the first example on calculation of the standard deviation, and here we calculated the population standard deviation of an individual series, the data which is not grouped, ungrouped data. Anybody have any question on this one? Look like there is no question. Now what I'm going to do is I'm going to stop sharing this one, and I'm going to show you how we can calculate the standard deviation of this data set using calculator. So please follow along with me. What you'll do is you'll go to stat, And then number 1, you have edit. So hit that enter. And then in list 1, enter the data. In list 1, enter the data. So this is how we can check our work. Enter the data, which is 10. Then we have a 60. Then we have 50. Then we have 30. Then we have 40. Then we have 20. Is that right? So this is the data that we have. Now, after you enter the data, make sure you follow along with me. After you enter the data, go to stat again. Here is your stat. Go to stat. Now, this time you'll go to calculate. Okay, go to calculate. We are still working on one variable stat. So hit enter. Your list or the values are entered in list 1, which is good. If there is anything in frequency, you remove that and come down and hit calculate. And you'll see that here we have, this is your, here is a sigma, that is your population standard deviation. And we got 17.078 if you round to 4 decimal places, 3. So 17.0783. If you want to get the values up to 4 decimal places all the time, this is what you can do. You can go to mode, and then here you can see here we have the numbers. Always set this to 4 and it will give you answer up to 4 decimal places all the time. If I go here and select that 4, then whatever calculation I perform, I'm going to get all answers in 4 decimal places. If I repeat the process like stat, then calculate, then number 1, and then come down here and calculate. Now you'll see the standard deviation is 17.0783. And in the first step, we calculated the mean. It was 35. Check here. You can see it is 35 again. Any question? Okay, if you can mute your mic, that'll be great. Okay, we did the first example, and you have seen that there's a lot of math there. That was the easy problem. We are getting into more challenging one now. Second example, here also we are asked to find the population standard deviation. Population standard deviation, that is sigma, variance, sigma squared, coefficient of variance, CVAR, which is standard deviation over mean times 100%. That's what we have to find, coefficient of variance for this data here. So this is a group data. And for group data, if you remember the formula for the group data, formula was this: standard deviation is equal to the square root of sum of f times x minus mean squared divided by, this is for population, so divided by n. That was the formula. So you can see here, we have the mean, and for the group data, in order to find the mean, if you remember, mean for the group data from the previous class is sum of f times x divided by n. So they have this x, they have the f, but we don't have f times x. So first we need to find that. So let's begin by creating this table down here. You can follow along with me. So first we write our x values, which are 2, 4, 6, 8, 10. Then in next column, we have the frequency. Frequency f is 4, 2, 3, 2, 5. Next column, we have to find, in order to find the mean, we need f times x. So let's find f times x in next column. So when we find f times x, we multiply 4 times 2, 8, or 2 times 4, 8, then 4 times 2, 8, 6 times 3, 18, then 8 times 2, 16, and 10 times 5, 50. We are also going to find the total. So please help me with this. Let's add these frequencies. Please add frequency along with me and tell me what you'll get. You have 4 plus 2 plus 3 plus 2 plus 5. What did you get?
16.
16, right?
Mhm.
Okay, let's add f times x now. Let's add these numbers, which is 8 plus 8 plus 18 plus 16 plus 50. What did you get?
100.
100. So what will be our mean? Let's substitute here. So the mean will be equal to, so sum of f times x, if you add all these, that is 100. And then we are dividing this by the total, that is 16, which is equal to, how much is 100 divided by 16 in your calculator?
6.25.
6.25, very good. So we got the mean. Okay, we got the mean. This is what we know from last class. But what we are exactly looking for is x minus mean squared, and we have to multiply by f. That is exactly what we are looking. So let's do that here in next column. So what I want is, see, I want, this is a little tricky. So I want f times x minus mean squared. F times x minus mean squared. I need that. F times x minus mean is squared. And I have to add all that. So this is how it works. Let's try here and make sure you follow along with me. So first what you have to do is you have to find this difference. X minus mean. X is 2. 2 minus 6.25. What do you get? Do it in your calculator. 2 minus 6.25. What do you get?
Negative 4.25.
Negative 4.25. That is the value of x minus mean. Now we have to square that. So hit that square button in your calculator and tell me what you'll get. You should get
18.06.
right, 18.0625. That is the value of that. Now you have to multiply that by frequency. We are doing for the first column. So if you multiply that by frequency, frequency is 4. Multiply that by 4. And what did you get?
72.2500.
72.2500 after that. See, it takes time, we get that value. So what we can do here is, in order to get those values, okay, in order to get these values, we need to use our calculator. So I'm going to stop sharing this screen and share calculator with you, and I can show you how we can find all these values directly in the calculator. So in your calculator, first you'll go to stat, and then number 1, edit. So in list 1, you are going to input your x values, which was 2, 4, 6, 8, 10. Okay. And in list 2, you are going to input the frequency, which was 4, 2, 3, then we have 2, and then we have 5, if you remember. In list 3, we already have f times x. We already calculated. If you want to write, you can also do this. You go there. Then it is f times x. So it is L2 times L1. So you can type second and then 2, therefore L2 times second times second and then 1. So L2 times L1 and enter. You'll get those values. We already have this in our table, 8, 8, 18, 6, 50. We already did that. But in next column, now you have to be very careful here. You go to the 4th column, you go up here and select that L4. What we need is F times F, frequency is in L2. So F is L2. So first type L2, second and 2, that is L2. F, then we have times, this is your times multiplication sign. Then parenthesis begin, okay, because you have F times X minus, X is this one. X are the values in L1. So second and then 1 minus the mean. We calculated the mean. Mean was 6.25. So 6.25 is the mean. See, we are typing f times x minus mean, then close the parenthesis and hit this square. And if you remember, we already calculated this first one manually and we got 72.25. Let's hit enter, you'll get all of them. Enter. See, we got 72.25 and everything else is there. So we can use calculator to make our work fast. So please copy this now. So now we have these numbers here, which is f times x minus mean squared. Now please add those numbers using your calculator. So I got 159.063. I hope you got the same. Now let's use this information to calculate the standard deviation. Now, the standard deviation sigma is equal to, see, this is our formula, which is square root of the sum of f times x minus mean squared. Sum of all that is this, which is 159.063, and divide that by n. N is the sum of frequency, which is 16. Please type that in your calculator. All you have to do is square root of this divided by 16. Please follow along with me. Square root of 159.063 divided by 16. You should get 3.153. That's your standard deviation. Next, we need variance. That is the square root of the standard deviation. So standard deviation is 3.153. We need to square that. 3.153. Square that in your calculator, 3.153, and hit square. You should get 9.9414. And the last thing we are calculating here is the coefficient of variance. That is the formula. So coefficient of variance. Is there a question?
Yeah, I have a different answer on the sum of the f x minus.
Everybody has
Yeah,
the
I got
different
10 point. I got 10 point. Instead of the 10.1875, I got 10.125.
Yes.
10.125.
Yes, 125.
10.125. That's right. That's right. You are right. 10.125. So what is the sum then?
The sum is 159.0005. 3005.
159.00
0, yeah, 3 zeros.
and 5, right? 0005. So this value will be different then. From here, it's going to be different. Let's do that again. Thank you. So when you find the square root, let's do that again. The square root of 159.005 divided by 16. So you got, I'm pretty sure you got 3.1524, right? And the variance is 3.1524 square. So 3.1524 square. That would be 9.9376. And the coefficient of variance is the standard deviation, this value, 3.1524 divided by mean. Mean is 6.25 times 100%. This session is about to expire. If it expires, we'll come back in 10 minutes. Please remember that. So the coefficient of variance is, now divide this and multiply by 100. 3.1524, divide that by 6.25, which is mean, and multiply that answer by 100 to get in percentage. I got 50.4384%. Is that what you get?
Yes.
That is the coefficient of variance. This is your variance, and that is the standard deviation. So we were able to calculate the standard deviation for 2 problems. And as I said, the session is about to expire. We are going to end here. And after we end the session, we'll come back in 10 minutes. So 10 minutes break. If I am late, the reason is it's taking a little more time to export the video. Okay?
Okay.
Yes, no?
Yes.
Okay, so I'm stopping this.